anytime you hear of the word hydroxide, I should see the chemical symbol OH. Another radical is nitrate. Nitrate is NO3. We said radicals have charges, but when writing the formula, we don't include the charges. We are just showing their charges because we said a radical, if you remember well how we had defined a radical, as a group of atoms with a net charge and act as a unit during a chemical reaction. Other radicals, we have hydrogen carbonate, that is HCO3 minus, and we have hydrogen sulphate, HSO4 minus. So these things are they don't look hard if you can be going through them each and every day. Just when it will only take you a week for you to memorize or to remember that HSO4 is hydrogen sulfate, HCO3 is hydrogen carbonate, NO3 is a nitrate, OH minus is an hydroxide, NH4 is ammonium, and Ag is silver, H is hydrogen, Br is bromine, chlorine, fluorine, potassium, sodium, and lithium. Let's move swiftly to valency 2. Valency 2 now, they require to lose 2 electrons. So if they require to lose 2 electrons, it's either they're in group 6 or they're in group 2. If they're in group 6, they'll gain 2 electrons. If they're in group 2, they lose 2 electrons. Still brings you back to the definition of valency, the number of electrons an atom loses or gains to become stable. Silver, we have silver, they fall under what we refer to as transition elements. For transition elements, now their valency are constant. They don't now work with losing and gaining. So let's start with alkaline earth metals, or group 2. We have beryllium, Be. We have magnesium, Mg. We have calcium. We have barium. That's all. These are alkaline earth metals. They fall in group 2 of the periodic table. Beryllium, magnesium, calcium, and barium. Group 6. Group 6, we have oxygen and sulfur. They gain 2 electrons, oxygen and sulfur. And also there are some other transition elements which have valency of 2. We also have zinc. Zinc is a transitional element or metal and has valency of 2. Now let's move to the radicals. Which radicals have valency of 2? We have carbonate, CO3, 2 minus. Remember, radical must always have a charge. We also have sulphate, SO4, 2 minus, valency 2. We also have a sulphite. Sulphite is SO3, SO3, 2 minus, has a valency of 2. Also, I'm supposed to include a nitrite, which reminds me of a nitrite. Nitrate is NO3, nitrite is NO2, NO2 minus. So nitrate and nitrite also have valency of 1, just the same way sulfate and sulphite. But we don't have carbide. We only have sulfate, sulphite, nitrate, nitrite. So we are moving well. Now let's move to valency 3. Valency 3, they need to lose 3 electrons. So they're either in group 3 or they're in group 5. If they're in group 3, they'll lose 3 electrons. If they're in group 5, they'll gain 5 electrons. So an common element in group 3 is boron, B for boron. We also have Al, which is aluminium. Those are the 2 elements at our level from period element number 1 to 20, though the list goes down. Then let's move to group 5. The other elements with valency 3 are group 5. We have P, which is phosphorus, and we have N, which is nitrogen. Why does nitrogen have a valency of? Though nitrogen behaves some elements. We have some elements which might change their valencies, and the valencies is not constant. You'll find the name on the element. Now we have the elements with their valencies. Now let's see how we can apply the valencies to write the chemical formula. So we'll be writing out the chemical formula of each element. So let's start with magnesium fluoride. Magnesium fluoride. So if you want magnesium fluoride, you have to know the symbol of magnesium is Mg. Then know the symbol of fluorine is F. Then now you need the valencies. So magnesium, where does it fall? It falls under valency 2. So the valency is 2. Fluorine falls under valency 1. So the valency is 1. Then we always interchange the valencies. Don't forget that. Always interchange the valency. And when you interchange the valence, you write now the number as a subscript, not as a superscript. So we'll write it as Mg F2. If it's a 1, there's no need of writing, because the formula tells you the ratio. So already I'm seeing it's only 1 magnesium. There's no need of putting a 1 to show that it is 1. But if there are 2, there's a 2. That's a ratio. So it means magnesium and fluorine will bond in a ratio of 1:2. 1 magnesium bonds with 2 fluorines. That's the first formula. Let's move to calcium oxide. Calcium oxide. So if we want calcium oxide, we take the symbol of calcium, Ca. The symbol of calcium is Ca. We write its valency 2. Oxide, oxygen. Oxygen, the symbol is O. The valency is still 2. So remember, we have said that these valencies are ratios. So if they are ratios, they can always be simplified. From mathematics, we know that a ratio can always be written in its simplest form. So if the ratio is 2, 2, we can simplify that ratio to be 1, 1. 1, 1. So it means calcium and oxygen will bond 1 in a ratio of 1:1. So now the formula will just be CaO. If it's a 1, we don't need to write 1, Ca1, because already we are seeing that it's 1 calcium. Let me give you another example. We have copper 1 oxide. Copper 1 oxide. So some elements, some compounds, it's easier to know the valency. You don't need to cram. That's why I didn't include copper here. Because any compound of copper, you'll be told copper can take varying valencies. Sometimes it can be copper 2 sulphate. So if it's copper 2 sulphate, the valency of copper there will be 2. If it's copper 1 oxide, the valency of copper there is 1. So if the name has a Roman number in between, it tells you the valency of the element which was coming before it. So this one is the valency of copper. So copper is Cu. The symbol of copper is Cu, and its valency we have been told is 1 because the compound is called copper 1 oxide. The symbol of oxygen is O, valency will be 2. After getting, this ratio cannot be simplified, so after having that valencies, what we do, we just interchange the valencies. So the 2 comes here and the 1 comes here, so the formula will be Cu2O. Cu2O, because we have interchanged the valencies. You can try at home. There's carbon 2 oxide and there's carbon 4 oxide. Write the formula of those 2. There's carbon 2 oxide and we have carbon 4 oxide. Carbon is C. The symbol of carbon is C. Here, the valency of carbon will be 2, and here the valency of carbon will be 4. So just try to do it at home, and you can use the numbers below your screen to send the answers and to confirm if what you have done is correct. Let me give you another one. We have ammonium sulphate. We want to write now for ammonium sulphate. Ammonium sulphate. Ammonium sulphate. Ammonium sulphate. Ammonium. Ammonium is a radical. Here it is NH4. We don't take the charge. When you are writing the formula, don't take the charge. Just take the valency. So we'll take NH4, and the valency is 1. This 4 is not a valency. Some of the mistakes students make, they take the 4 to be a valency and they interchange it. The 4 is the formula. Ammonium is 1 nitrogen and 4 hydrogen. Anytime I hear of ammonium, I should see NH4. Don't remove the NH4. So sulfate, ammonium sulfate. Sulfate is SO4. The valency is 2. We cannot simplify. Don't simplify the 4s. The 4s are not valencies. Those are formulas. Those are the formula of the sulfate. So when we interchange, it will be NH4. Because you want to put a 2, I have to put the whole of ammonium in brackets, because the whole ammonium is the one which will react in the ratio of 2:1. If you don't put a bracket, it will be now NH42, of which you have changed the formula of ammonium. So always if it's a radical, and radicals are these ones: ammonium, hydroxide, nitrate, hydrogen carbonate, hydrogen sulfate, nitrite, carbonate, sulphate, and sulphite. And also here we add phosphate. I'd forgotten to add phosphate, which is also has a valency of 3. It's a radical because the charge is 3 minus. The charge is 3 minus. So anytime you want to put a number below a radical, you have to put the radical in brackets. So because I want to put a 2, I'll put NH4 in brackets. 1. There's no need of putting 1. We said if it's 1, we just leave it at S as S or 4. So this is the chemical formula of ammonium sulfate. Ammonium sulfate. Let me give you now aluminium carbonate. Aluminium carbonate. We look at aluminium carbonate. Aluminium carbonate. So you have, remind yourself what's the symbol of aluminium and what's the symbol of a carbonate. Only that's the first step you need to start with so that you can get the actual or correct formula. So aluminium is Al. So it's Al. What is valency? Valency 3. Carbonate is CO3. What is valency? Valency 2. Second step, 3 and 2 cannot be simplified. There's no number which can divide both 3 and 2. So here we just interchange the valencies because it cannot be simplified. Then we get what we have Al2CO3. We said any radical, when you want to put a number, you always have to put the radical in brackets. So this 3 for aluminium comes here. Remember, this 3 for CO3, this 3 is not a valency. This 3 is the formula of the carbonate. So that is aluminium carbonate. So I'll add you more so that you can do practice. You can copy those and do them during your free time so that you can remind yourself. The goal is to memorize the valencies and the formula. And for you, the only way to memorize them is doing it over and over and over again. And when you do that, it makes your chemistry to be easier. Because the only thing which makes students not to fear chemistry is they don't understand. When you get Form 2, then you start now getting chemical formulas and chemical reactions. That kills your spirit or it kills your morale towards chemistry. But when you are okay with this, you'll be able to see chemistry as an easy subject. So the goal or the trick is just do it over and over again. Even you can create your own compounds. You can say, let me now write silver sulfate. Let me write sodium phosphate. Let me write calcium phosphate. You can also create your own questions. And let me add you 3, then the others you can create on your own. So we'll write iron 3 chloride, iron 3 chloride. Iron 3 chloride. Iron is Fe. This 3, remember, what does it tell you? It tells you the valency of iron. The second will be sulfur 4 oxide. Sulfur 4 oxide. And the last is ammonium nitrate. Ammonium nitrate. Ammonium nitrate. So there you have, we have iron 3 chloride, we have sulfur 4 oxide, and we have ammonium nitrate. So those are chemical formula. Now let's move to chemical equations. Those are chemical formulas, so let's move to chemical equations. And in chemical equations, I'll give you summaries of some reactions so that when you know this, if this is reacting with this, automatically what are the products I'm supposed to get? If I'm reacting a metal and an acid, what are the products? Because the products will always be the same. The products will never change. So if you can get the summary of, if we always am reacting an acid and a metal, then you work also on your writing chemical symbols and chemical formulas, chemical symbols and chemical formulas there, then it will be easier for you to write a chemical reaction. So we start with the first reaction. The first reaction, the most common reaction you'll ever get in chemistry is a reaction between an acid and a metal. When you react an acid and a metal. And remember that to show that all these things are related, we usually hear of acidic rain or some places where there is a lot of environment pollution. Usually the gases which are being released, like sulfur 4 oxide, you're supposed to write the formula of sulfur 4 oxide. A sulfur 4 oxide is an acidic gas. So when it is released to the atmosphere, it mixes with rainwater and dissolves. And when it mixes with rainwater and dissolves in that rainwater, the rainwater turns to be an acidic rain. So what will happen if you have a rooftop which is made of a metal? The acidic rain will be corroding the metal slowly by slowly, and you'll be wondering why is the metal being corroded? Because of the pollution. Pollution led to formation of an acidic rain, and an acid will always react with a metal. An acid will always react with a metal. And when it reacts with the metal, what do you get? You get salt plus what? Plus hydrogen gas. Acid plus metal, you get salt plus hydrogen gas. Salt plus hydrogen gas. So, let me help you to how to be able to know the name of the salt. Because each element, each salt has a name, and the name depends with the metal you have used and the acid you have used. So the common acids we have H2SO4. This is sulfuric acid. H2SO4 is sulfuric acid. And the salt, always the salt it will give you will be a sulfate. And remember, sulfate is a radical, and we have its valency there. So anytime you're reacting a metal with a sulfuric acid, you'll get sulfate. We have HCl. HCl is hydrochloric acid. HCl is hydrochloric acid. Anytime you react something with hydrochloric acid, the salt will be a chloride. The salt must be chloride. And the other common acid is HNO3. Nitric acid, HNO3. Nitric acid will always give you a nitrate. Nitric acid will always give you a nitrate. So let's say we have sulfuric acid here. Sulfuric acid is reacting with a metal. The metal should be higher than hydrogen in the reactivity series. Because when an acid reacts with a metal, this hydrogen is usually displaced. So that metal should be reactive. So let's take sulfuric acid plus, let me give zinc, plus zinc. So the name of the salt, we take the name of the metal and sulfuric acid. So the name of the salt will be zinc sulfate. Zinc sulfate. Because we have said if it's sulfuric acid, the salt should be sulfate. Plus hydrogen gas. Plus hydrogen gas. So that's how the reaction. If you have zinc and you react with sulfuric acid, you get the salt, and the salt is zinc sulfate, and you get the gas, which is hydrogen gas. This is for Form 1. Form 2 onwards, you're not supposed to write a word equation. You're supposed to write a chemical equation, and actually that's where we are heading to. So let's write the chemical equation for this reaction. Sulfuric acid, this acid, there are only 3. Memorizing them, it's not rocket science. We can know that sulfuric acid is H2SO4 because 2 hydrogens were combining with 1 sulfate. And because it's a dilute acid, you have to put the state, aqueous solution, AQ. AQ stands for aqueous solution, plus Zn. Zinc, it's a metal. Metals are solid in nature, so we put S. Zinc sulfate, we want zinc sulfate. Now here, we need to use our valencies. So zinc, here I'll not repeat the part, zinc, Zn. Sulfate, SO4. Both have a valency of 2. So if both have valency of 2, the ratio will be simplified to be 1, 1. So it means we only have 1 zinc and 1 sulfate. Because it's a salt, it is aqueous. It's a salt which is in aqueous solution or aqueous form. So plus H2. Why am I writing hydrogen as H2? Not because the valency is 2. In chemistry, we have some gases which we refer to as diatomic. And those gases include oxygen. It means they cannot exist as one atom. They have to combine with another oxygen to be O2. Even hydrogen is a diatomic gas. So anytime hydrogen is on its own, should be written as H2. When it's on its own like this, it should be written as O2. The same thing applies with halogens. Chlorine, bromine, and fluorine. When they're appearing on their own, they should be written as Cl2, F2, or Br2. Another thing after writing chemical equation is to balance the chemical equation. So how do we check if the chemical equation is balanced? On this side, I have 2 hydrogens. On the other side, I have 2 hydrogens. Hydrogens are balanced. Sulfate is SO4. I have 1 sulfate. I have 1 sulfate, SO4. Zinc here 1, zinc 1. So all the elements in that reaction are balanced. So we don't need to put any other number. Let me give you another example for still acid plus metal. We want to look now for magnesium. Hydrochloric acid. Hydrochloric acid plus magnesium. Acid plus metal, you get salt plus hydrogen gas. So if you are using hydrochloric acid, the salt should be chloride. So automatically the name of that salt will be magnesium chloride. Magnesium chloride. Salt plus hydrogen gas, so plus hydrogen gas. That's what you get. This is a word equation. We need to write the chemical equation, not the word equation. So you very fast you can write the formula of HCl. Sorry, not HCl, but hydrochloric acid. The hydrochloric acid is HCl. And I've emphasized that any acid, when it is dilute, it's always in aqueous form. So we say HCl, then we put bracket, aqueous. Magnesium, we go back to the table, Mg. Magnesium is Mg. And it's a metal, so the symbol will be solid. We get the salt magnesium chloride. Magnesium chloride is magnesium and chlorine. So here we have to use valency and come up with the formula of magnesium chloride. Magnesium is Mg, valency 2. Chlorine is Cl, valency 1. When you interchange the valency, the 2 will come to chlorine and the 1 will go to magnesium. So the formula will be Mg, we don't need to write 1, Cl2. That's 2 for magnesium. The valency of magnesium has come to chlorine. 1 has come to magnesium. And always salts, most salts, soluble salts are aqueous because they are soluble in water. So this one will be aqueous plus H2, gas. Hydrogen gas, it's a gas, so we put a G in brackets. So that's the chemical equation. Last step now is to see if the chemical equation is balanced. Are all the elements balanced on the reactant side and the product side? So let me start with hydrogen. On this side, we have 1 hydrogen. The other side, we have 2 hydrogen. They are not balanced. Let's move to chlorine. 1 chlorine, 2 chlorine. Still chlorine are not balanced. Magnesium, 1 magnesium, 1 magnesium. This 2 is not for magnesium. This 2 is for chlorine. So magnesium are balanced. The only thing which is not balanced is hydrogen and chlorine. So if I put a 2 here, I'll make these hydrogens to be 2, the same as the other side. And also this chlorine will be 2 because the 2 is coming in front. So it means both are 2, 2. So with that, you have managed to balance your chemical equation. So that's the first common reaction between an acid and a metal. And in Form 1, when you are looking at preparation of hydrogen in the laboratory, we usually react a metal and an acid. Because when you react an acid and a metal, your product will be hydrogen. So that's the only way you can produce hydrogen gas in a lab, reacting an acid and a metal. So I'll give you 2 questions you can attempt for reactions between an acid and a metal. Let me dictate the first one. You can write zinc plus hydrochloric acid, zinc plus hydrochloric acid. Start with the word equation. Zinc plus hydrochloric acid, you need to write the products. What will you get as your products? Then you write the chemical equation and try to balance it. Aluminium plus sulfuric acid. Aluminium plus sulfuric acid. We haven't used nitric acid. We also have to add one for nitric acid, where you can say calcium plus nitric acid. Calcium plus nitric acid. So we have zinc plus hydrochloric acid, aluminium plus sulfuric acid, and calcium plus nitric acid. Remember, your products will always be a salt and a water. How do you get the name of the salt? If the acid is sulfuric, the salt must have the word sulphate. If the salt is hydrochloric, the salt must have the word chloride. And if the salt is nitric, the salt must have the name, if the acid is nitric, the salt should have the name nitrate. That's acid plus metal. Now let's move to other type of reactions which you will encounter as you are studying chemistry from Form 2 to Form 4. We'll also have acid plus metal oxide. You can always react an acid and a metal oxide. A metal oxide, remember now, has combined with oxygen. So it's not on its own. So number 2, is acid plus metal oxide. And if it's acid plus metal oxide, now the product changes. Now you get a salt will be there, but instead of hydrogen, you get plus water. So if it's an acid and a metal oxide, you will not get salt and hydrogen gas, you get salt plus water. Let's look at one example. We have zinc, we have nitric acid plus zinc oxide. Zinc oxide, metal oxide, zinc oxide. Zinc is a metal oxide. So the salt we have said always comes from the metal and the acid. So if it's nitric, it's called zinc nitrate because my metal is zinc. So zinc nitrate plus water. So zinc nitrate plus water. And nitric acid, this is the word equation. Now you have to move to the chemical equation. So nitric acid, HNO3. Here it's formula for nitric acid, HNO3. All dilute acid are aqueous, so AQ. Zinc oxide, ZNO. Here now you have to use valencies. How did I come up with zinc? Zn, valency 2. Oxygen, O, valency 2. 2, 2, they simplify. So only one zinc and one oxygen. That's how the formula of zinc oxide became ZNO, solid. I want zinc nitrate. Still, I love to use valencies. So zinc is Zn. Nitrate. Nitrate is here, NO3. NO3. The valencies are not the same. The valency of zinc is 2. The valency of nitrate is 1. So I have to interchange the valency. So the 2 for zinc will come here for under nitrate. And because nitrate is a radical, and you want to put a 2, you have to put it in brackets. That's what we had talked earlier when we are looking at chemical formulas. So we have zinc nitrate. It's a salt, a soluble salt. If it's a soluble salt, aqueous. Plus water. Water is hydrogen and oxygen. What's the valency of hydrogen? 1. What's the valency of oxygen? 2. So when you interchange the valency, the 2 will come to hydrogen, so you get H2O. H2O. The 2 for oxygen comes here. If it's a 1, we have said there's no need of writing 1. So water automatically we know it's a liquid, so we put L. So that's the chemical equation. Second step is the chemical equation balanced. Let's start with hydrogen. 1 hydrogen, 2 hydrogen. Hydrogen are not balanced. Let's take with nitrate, NO3. 1 nitrate, 2 nitrate. So putting a 2 here will balance the hydrogen and will balance the nitrate. This oxygen will be balanced. 1 oxygen, 1 oxygen. 1 zinc, 1 zinc. So that's a chemical equation between an acid and a metal oxide. So at home you can attempt to write this one. Magnesium oxide plus hydrochloric acid. Magnesium oxide plus hydrochloric acid. And you can send your answer through the number below your screen, and we can see how you have done. The second one is iron 3 oxide plus nitric acid. Iron 3 oxide plus nitric acid. Magnesium oxide plus hydrochloric acid. Then the second is iron 3 oxide plus nitric acid. So that's another reaction between an acid and a metal oxide. The third reaction, which you'll always encounter in chemistry, is now, most of the reaction you can see they are involving an acid. Most of the reactions, that's the most common chemical in our lab, the acids. So most reactions will be involving the acids. So we look at acid plus metal carbonate. Acid plus metal carbonate. Now, this is a metal carbonate. So you get salt, you get water, and you get carbon 4 oxide. Carbon 4 oxide. So if you have a metal carbonate plus an acid, always you'll get a salt, water, plus carbon 4 oxide. The name of the salt, we have said it's easier to get the name. You just take the metal and the acid. Like in form 2, towards the end, when you look at preparation of carbon 4 oxide, you'll use this reaction. You take an acid and you react it with a metal carbonate. Because when you take an acid and a metal carbonate, automatically you'll get carbon 4 oxide, which has a wide range of uses. It's used as a fire extinguisher, is used by ice cream vendors. So the gas, if you need it Always you need a metal, carbonate, and an acid. So then you take hydrochloric acid plus calcium carbonate. If you have hydrochloric acid plus calcium carbonate, the salt will be calcium chloride because hydrochloric is chloride. So calcium chloride plus water plus carbon 4 oxide. That's our word equation. Let's look at the chemical equation. Hydrochloric is HCl. If it's HCl, it is aqueous because all dilute acids are aqueous solution. Calcium carbonate now we have to use the valency. Calcium is here valency 2, carbonate is here valency 2. Valency 2, they simplify to be 1, 1. So 1 calcium, 1 carbonate. So calcium carbonate will be CaCO3, and it is a solid. Most carbonates are solids because they are insoluble in water. Most subcarbonates are solids. You get calcium chloride, calcium and chlorine, calcium chloride. Valency of calcium 2, valency of chlorine 1. Interchange the valencies. The 2 for calcium will go to chlorine. So you'll get CaCl2 after interchanging the valencies. Then this is aqueous. It is aqueous because it is a salt, a soluble salt. Water, we now know the formula of water is H2O, which is a liquid, plus carbon 4 oxide. Carbon 4 oxide, let me do it here. The valency of carbon is 4 because it's carbon 4 oxide. Oxygen, the valency is 2. It's a ratio. If it's a ratio, it can be simplified. So when it is simplified, that ratio will be 2:1. Then after simplifying the ratio, you interchange. So it becomes CO2. That's why the formula of carbon 4 oxide is CO2. So CO2 gas. So those are the first 3 reactions which you can write. And let me see if you have any questions at home. If you have anything which you want us to clarify, so that you can clarify. And remember, we are saying that writing a correct chemical equation is a plus in understanding chemistry. So if you can work from there, you can always, if you can work on writing chemical equations, just give yourself a month to write chemical equations. So we have, hello Mwalimu, I'm watching from Wingi. Thank you people from Wingi. From 4 graduate. That's just a compliment. He likes chemistry. And I hope you can send the message also to other students so that we can create a good attitude towards the subject. You have said that the valency of ammonium sulphate. Oh, we don't, not the valency of ammonium sulphate. Ammonium is a radical. Sulphate is a radical. So I want the formula of ammonium sulphate. How will you get the formula of ammonium sulphate? We write ammonium here, NH4. And the valency is 1. We write sulphate here, SO4. The valency is 2. So the formula, you becomes NH4 brackets 2 SO4. So the formula, not the valency. Each radical has its own valency. Now, Collins from St. Teresa's, please give me a lecture on how to write ionic equations. Yeah, okay. When we look at the topic salts, we'll look at how to write ionic equations. So Collins, don't worry. During our next lesson, I'll work on that. Bruno, you have written as word equation. Now we also want to write the chemical equation between zinc and hydrochloric acid. Yeah, but it's correct. You'll get the salt to be zinc chloride and hydrogen gas. No, Chappelle from LD or Eldoret is saying that nitric acid will never give you a nitrate. It can only give you, when you're writing a nitric acid, it doesn't give you a nitrite. It will always give you a nitrate. But there's another reaction. I'll show you how a nitrate can be converted into a nitrate. When you hit a group 1 nitrate, it becomes a group 1 nitrite. Like when you hit sodium nitrate, it changes from sodium nitrate to sodium nitrate. But nitric acid doesn't give you nitrite. And thank you, Kate, for watching from Nyandarua, and I hope you do the same in trying to write the chemical equations. So students, those are our most common reactions. We have said acid plus metal oxide, and acid plus metal carbonate. And I've done one reaction here for acid plus metal carbonate. So let me give you one attempt. You try to do it at home. If you have sulfuric acid plus magnesium carbonate, sulfuric acid plus magnesium carbonate. Try to write that equation, both the word equation and the chemical equation. Sulfuric acid plus magnesium carbonate. The other one you are going to write on is, we have written for nitric acid. This is hydrochloric acid. So nitric acid plus sodium carbonate. Nitric acid plus sodium carbonate. So we have sulfuric acid plus magnesium carbonate and nitric acid plus sodium carbonate. Products: salt, water, and carbon 4 oxide. The other reaction which you usually encounter is on titration, is a reaction now between an acid and a base. When you do titrate an acid and a base, what are the products which you'll get? An acid plus base. And base, for you to know a base, is always an hydroxide. The same way, the one similarity about all these acids, they have the element hydrogen. For something to be classified as an acid, it must have the element H, hydrogen, H2SO4, H. So same thing with bases or alkalines solutions. For anything to be a base, it must have the hydroxide ion, OH. Any base, calcium hydroxide is a base, sodium hydroxide is a base, and zinc hydroxide, aluminum hydroxide, provided it has the name hydroxide. So when you have an acid plus a base, that reaction is referred to as neutralization reaction. That reaction is referred to as neutralization reaction. That's why there's a poet, Teardrop. He says that unaka base ndio neutralize acid. So when you see base neutralize acid, because an acid and a base neutralize each other. So what you get is the same as the acid plus metal oxide. You get a salt and water. And because water is neutral, that's why the reaction is referred to as a neutralization reaction. So let me take a base, let me take an acid. We have sulfuric acid. Sulfuric acid, and we take a base like calcium hydroxide. So sulfuric acid plus sodium hydroxide. Let me use sodium hydroxide, not calcium hydroxide. Sodium hydroxide. So, because it's an hydroxide, it's a base. Which salt do you get? We said the salt always depends which metal are you using and which acid. So because it's sodium and sulfuric, the salt will be sodium sulfate. Sodium sulfate. Plus water. That's the word equation. Sodium sulfate plus water. Sodium sulfate plus water. Now we want the chemical equation of a neutralization reaction between sulfuric acid and sodium hydroxide. Sulfuric acid, H2SO4, aqueous, plus sodium hydroxide. Sodium hydroxide is a compound, so you have to know valencies. Sodium is Na, hydroxide is OH. Both have a valency of 1, so just one sodium and one OH. So you plus NaOH. Because we don't want to put any number, there's no need of putting brackets. But if you wanted to put a number under OH, because it's a radical, you have to put brackets. So NaOH, all hydroxide are aqueous, bases also are aqueous solution. You get sodium sulfate. You get sodium sulfate. So if you have sodium sulfate now, what's the valency of sodium? Na. What's the symbol of sodium is Na. Then what about sulfate? SO4. Valency is lazima to interchange. So valency of sulfate is 2. Valency of sodium is 1. Interchange. The 2 of sulfate comes to sodium. So Na2SO4 plus. H2O. So sodium sulfate is aqueous and water is liquid. Sodium sulfate is aqueous because it's a salt. We have said most soluble salts are aqueous. That's the equation. Last step, confirm if the equation is balanced. 2 hydrogen, 2 hydrogens, 1 hydrogen. Sorry, 1 hydrogen plus 2 hydrogens, those are 3 hydrogens. Then on the other side, we have 2 hydrogens. So hydrogens are not balanced. Sodium here is 1, Na2, sodium are 2. Sulfate is 1, sulfate is 1. Sulfate is balanced. So what is not balanced is hydrogen and sodium. So let me start by balancing sodium. Because Na2, I put a 2 here. If I put a 2 here, I've made now hydrogens to be how many? 2 plus 2, 4. So on this side, the hydrogens are 4. So what about the other side? The hydrogens are 2. So 2 times 2 is 4. So if you just put a 2 here in front, then you have also balanced the hydrogen. So you'll be having 4 hydrogens and 2 oxygen. And the equation will be balanced. So that's the reaction between a metal and not a metal, a base and an acid. And we have said we refer to it as a neutralization reaction. So at home you can attempt writing hydrochloric acid plus aluminium hydroxide. Hydrochloric acid plus aluminium hydroxide. The first four equations we have covered, they all involve an acid and another compound. So the last one which I'm going to look at is now when you have a metal and water. Metals such as sodium and potassium, alkali metals, these two, they are very reactive. They can react with water. Actually, when you put potassium on the surface of water, just a small piece can cause an explosion. So the reaction, when they react with water, what do they form? What do they form? So that is metal plus water. Metal plus water. Metal plus water. You get metal hydroxide plus hydrogen gas. And the only metals, calcium. Also calcium is a very reactive metal. Also it can react with water. So let me take an example, sodium, Na. Plus water, we know it's H2O. You get solid. And this is liquid. You get the metal hydroxide. The metal which you have used is the one which will give you the hydroxide. So you get sodium hydroxide, NaOH, aqueous, plus H2, gas. So all hydroxides are aqueous. NaOH, both have a valency of 1. So sodium hydroxide should be NaOH. So you can try to write between copper, not copper, but potassium and water. At home you can attempt to write potassium plus water. So I hope the lesson has been of assistance, and this is the main thing. This part is where you need to put more emphasis. If you have that, if you have the table, you can be using it to write chemical formulas and those summaries. So let me see some of the questions which you have sent to the number. So we have Lee from Nakuru is asking the difference between electropositivity and electronegativity. Electronegativity is we have halogens. Halogens, they attract electrons. That's how they form ions. So when they attract electrons, we can say the one which attracts an electron very fast is more electronegative. The one which loses an electron, like sodium, is more electropositive. Because when you gain electrons, you become negatively charged. When you lose electrons, you become positively charged. So electropositivity is that state of losing an electron. Electronegativity is that state of gaining an electron. And they're usually valid. There's one element which will be more electronegative than the other. If it can gain electron faster, it's more electronegative. Like fluorine. Fluorine is the most reactive halogen. It's the most electronegative. Potassium is the most reactive alkali metal. It's the most electropositive. Let me look at another question. Anne is asking the formula of nitric acid is HNO2 or HNO3. It's HNO3. But we have two types of, this is the common nitric acid. When you form nitric acid, it can form the nitric acid of HNO2. But that nitric acid is usually readily oxidized to, this is the nitric acid which is stable. When you have HNO2, it's easily or readily oxidized into this HNO3. So the nitric acid which we use for reactions in the lab is HNO3. But because HNO2 it's not stable on its own. When it's around, it's just easily oxidized to be HNO2. How can I get help? Because very poor in chemistry from Kwale. I'm sure you can get good teachers from Kwale to assist you in chemistry. Joan, thank you for learning from Gatundu. What if you can receive equation without being balanced? Can you be given a mark? We call it a balanced chemical equation. So for the equation to be correct, it has to be balanced, because the balancing tells you in what ratio. Like this equation is not balanced actually. This equation is not balanced. The balancing will tell you the ratio. 2 hydrogens, so I put a 2 here and a 2 here. So it means 2 molecules of sodium reacts with 1 molecule of water to give you 2 molecules of sodium hydroxide and 1 molecule of hydrogen gas. So, but you can work with, when you start working with writing the correct chemical formula, you can build on balancing just slowly by slowly. Practice makes perfect. If you do more practice, it will just become simple in balancing. Vincent, Sir Vincent from E-Town. E-Town, is it Eldoret? Does rusting have advantages? Rusting, does it have advantages? No, rusting doesn't have advantages. Friction has advantages, but rusting doesn't have advantages because it causes that wear and tear. The machine gets worn out, so there's no advantage it has. How do acid react with the base? How do acid react with base? They form, we have said acid plus base, you get salt plus water. What's the difference between valence and valency? Nani anasema Maria Kani somo imebamba Rachel. Valency na valency is how many electrons it loses or gains. Valence is outermost. You see, when you are drawing, like if I want to draw magnesium, Mg, 2H2. So 2H2, the valence electrons are 2. We call them valence electrons because they are outermost. But now the valency of magnesium is 2. So valence is just like a noun and an adjective and a verb, not a noun and a adjective. There's a small difference. An English teacher can elaborate more on that. But valence is the outermost electrons. We call them, instead of calling them outermost, you can also call them valence electrons. But valency now is how many electrons is it gain? Let me give you a good example. Sulfur. Sulfur is 2H6. The valence electrons are 6, but the valency is 2. The valence electrons are 6. How many electrons is the outermost shell? Valency will be 2. So I hope that explanation gives you the difference between a valency and valence. Valency is the number of electrons it loses or gains. Valence is how many electrons does it have in the outermost energy shell. Chemical formula of calcium hydrogen sulfate. Just use the calcium is Ca, valency is 2. Hydrogen sulfate is HSO4, valency is 1. Interchange the valencies, then you'll get the chemical formula of hydrogen sulfate. What's the formula of hydroxonium ion? An hydroxonium ion, that one you encounter it in bonding, it's H3O plus. It's usually formed from water. When you add an hydrogen which has a charge, that's why the charge becomes plus. It forms an hydroxonium ion, but it does not exist on its own. You have to combine it with another compound. So, is nitrate acid with sodium hydroxide balanced? If it is, then balance it for me. Sorry, I dropped the question. You can just balance and then please forward. We check if we can correct on that. So thank you for your feedback and also for staying tuned. And I hope you have a good attitude towards chemistry and science subjects. And we'll catch you next time for another lively lesson. Thank you.